Hello and welcome. In this video I'm going to show you how to troubleshoot a breadboard circuit by checking the electrical potential difference around the circuit using a multimeter. So this diagram I have here shows the basic relationship between voltage, resistance and current. So if you think of this guy as the voltage or electrical potential difference that pushes the charges or the current around the circuit. Remember that current is just the flow of charge or the rate of flow of charge, and the resistance is what impedes the flow of current around a circuit. So if you bear these things in mind as we're troubleshooting our circuit, it can help you understand why your circuit may not be behaving the way you want it to. So here I've constructed on the breadboard a simple series circuit with a approximately 6-volt battery, a 180 ohm resistor and an LED. So we have from the positive terminal coming down here, flowing, the charge should be flowing through the 180 ohm resistor, then through the LED back into the negative terminal. So this circuit diagram represents the circuit I've constructed here. You can see that the circuit's not working, so we're going to use the multimeter to make some voltage measurements around the circuit and see if we can find out why the circuit's not working. So the first thing we can check is that the battery has energy. So you can notice that the multimeter is set on 20 volts. So this is the voltage area, and we're going to just check the voltage of around the circuit. So we have got around 6 volts, 5.86 volts at the battery terminals. So the battery's got energy. Sometimes we can have problems with the battery clip leads. They have solders and connections inside. Sometimes they break. So we can check that we still have got our 5.8 volts at the ends of the battery clip leads, and we do. Okay, so far so good. So these components are all okay. We can check the voltage across the resistor. We should have a voltage drop across there. Okay, so first sign that we have a problem, we have no voltage across the resistor. So if we've got voltage here and nothing across the resistor, then that means that there's no current flowing through the resistor. We can check the voltage across our LED, and if we get 6 volts here, which we do, we know that the resistor's okay, that we have a connection here, but that there is no electrical connection through this resistor. Through this LED. So that means that the LED is the problem. We can use an LED tester to confirm that the LED is in fact the problem. So I'll just show you how the tester works. So if I plug a good LED into the tester with about 20 milliamps of current, turn it on, the light, that LED works. If I try this LED, our faulty one, well, okay, it's very, very dimly lit, but it's we'll just try it with a smaller current. Okay, so with a smaller current, it's not really lighting up. So this LED is the problem in this case. Okay, this time I have a different circuit. It's the same design, a different LED, but this circuit doesn't appear to be working either. So we can repeat the process to see what the problem might be. So if we check the voltage or electrical potential difference between the ends of the battery leads, we can see that we have 5.86 volts. So we have energy being supplied for the circuit. We can check the voltage across the resistor. We have 3.4 volts, so this is promising. So we obviously have a current flowing in the circuit because we have a voltage drop across the resistor. And we have a voltage drop across the LED as well. So we have a current. So why isn't the LED lit? Well, one thing about LEDs is that they need a certain amount of current. Well, there's a current brightness response. So with a very, very low current, the LED will be very, very dimly lit. So if I turn out the light, we might be able to see that the LED is in fact lit. Can you see that? It's very, very dimly lit. So I can show you by just disconnecting the battery. So that's when there's no light in the LED, and there it is, dimly lit. So what's the reason for our low current in our circuit and our dimly lit LED? Well, because of the relationship between voltage, current and resistance that we looked at earlier in this video, we know that if there's a very high resistance in a circuit, then the voltage will have more difficulty pushing the current around the circuit, so the current will be lower. So it's likely that we have a high resistance in our circuit. Why would we have a high resistance? Well, probably because of this guy. It's probably a very high value resistor. We can check that with our multimeter. We can dial our multimeter around to this region and measure the resistance. So because I suspect it's a high value resistor, I can, well, I'll put it on to read up to 20,000 ohms, because I'd like to show you something else as well. So we can't measure the resistance in a powered circuit, not because it will cause any damage to anything, but we won't get an accurate value. So we can either unpower the circuit by taking out one of the battery leads, or we can pull the resistor completely out of the circuit. So just doing the first one. So the multimeter is reading 1 because the value is higher than the maximum scale reading. So this goes up to 20,000 ohms. Actually, could you see that? Let me just bring it back down here. Okay, so when I try to measure the resistance, I have the multimeter shows a 1. So that means that I need to change the scale, and I'll move it up so it can read up to 200,000 ohms. And it's still showing a 1, so I'll go up to 2 million ohms. Okay, so it's about 200,000 ohms, which is a very high resistance. Now the other way we can measure resistance is we just pull the resistor completely out of the circuit and pinch the ends, and it's jumping around quite a lot for some reason. Okay, it's stabilizing at around 200,000 ohms. I think one of the problems is that, like, the resistance of the human body is not so much more than that, and it's possible that by pinching it with my fingers I'm affecting the result a little bit. I'm just going to show you one last circuit that we can troubleshoot. So I'll just again check that we have potential difference across the battery leads, which we do. We can check the potential difference across the resistor. Again, this is similar to the first circuit where we have no potential difference across the resistor, which means no energy is being consumed by the resistor, which means that there's no current flowing through it. Okay, so why is there no current flowing through the resistor? We can check the potential difference between the resistor negative leg and the negative battery lead, and we can see that we've got the full 5.86 volts there. So that means that the circuit's broken somewhere between these 2 points, somewhere between the negative leg of the resistor and the negative battery lead. The circuit is broken. We can also look at the voltage across the LED. It's 0. So I now can have a close look at my circuit, and if the LED was broken, we'd have a potential difference across it. But the fact that it's 0 means that the circuit's broken somewhere in here. Now, what I can see now is that the negative leg of the resistor is not in the same row of holes as the positive leg of the LED. So that's a very common mistake. It's very easy to do, especially when you get older, which is not relevant to you young students, but it's certainly relevant to me. Okay, so I'll just move it into the same row of holes, and voila, the circuit is fixed. So just wrapping up, so in this video we've learned how to use a multimeter to trace the potential difference around a circuit and try and figure out where it's not working. In doing this, it really helps you to understand the relationship between voltage, current and resistance. It takes a while to become good at this, but it's a really worthwhile thing to do, to be able to troubleshoot your own circuits rather than always asking for someone else to find out why it's not working. So good luck, and good breadboarding.